This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to Ship It, the podcast all about what happens after you Git push. I'm your host, Justin Garrison, and with me as always is Autumn Nash. How's it going, Autumn?
Hey.
It is an exciting show. I'm so glad that Duan just jumped in because I messaged him like last week.
He makes networking accessible and interesting.
He mentions it in the interview that he likes going to in-person conferences and stuff more than virtual things. And that's the first time I met him, and I remembered him ever since then. So absolutely, if you get a chance to be at a conference, say hi, because he's fantastic to talk to and knows a lot. And it's super fun just to talk and learn.
He's very knowledgeable and he's got a great presence.
Yeah. So I was going to say the thing that I kind of learned out of the conversation was really just, I love how, like, I didn't realize he was in the military, and I didn't realize that he started with like just his first networking in IT was there learning OSI, because OSI for me came much later. I was like, I didn't know what the heck that even meant.
I've met a lot of people from the military. Maybe it's also because I'm more involved in the military community, but I've met a lot of people that start their networking career or like maybe hardware career or people that work in data centers like through the military. And I think it's amazing because it's a lot of like hands-on learning in that. So I think it makes really great networking in like hardware engineers.
Yeah, I really wonder how the education of in any sort of service differs from something like a boot camp or other areas you might try to go learn the same stuff, because it seems like a lot of the people that come out of that learning experience, it sticks with them for a really long time.
Well, when your lives depend on your networking abilities,
You gotta get higher.
It right. Well, not just that, but you're going to like scramble really hard to fix it, when it does break. So
did you have any big takeaways from the conversation?
I just thought it was another example of people in tech from different backgrounds, like having so much to offer, Yeah.
And also this conversation, I guess, meanders a little bit. We started networking and we end up in AI, but it's all kind of tied together still. There was a lot of these like fundamental learnings that played a role in all of the pieces of the conversation. So really fun.
I think a lot of our jobs are pushing us to do what we started, but then also pushing us to like have something to do with AI. Like people, it's getting more, and I think everyone's trying to figure out where they can put it in their tech stack and how they can be more efficient with it. Well, companies are. So it's kind of a shift that everybody's kind of dealing with right now.
And the people that are trying to go I've been learning a lot about it, but I'm mostly trying to find where to not put it in, right? Like what, like the experts are the ones that'll tell you when to not use something and why. And if I can tell someone just go do the machine learning thing instead of the Gen AI thing, maybe that's a better outcome, or just a straight, regex or if statement, right? Like let's find the lowest common denominator here to add value.
I'm always looking for something to be more efficient and to be more productive and to be better at building software. But I also think, for one, we can't talk about it if we don't know about it. We can't give our opinions, and people are always asking your opinions. And I don't want to say something like, people are always like, oh, I hate AI, or AI is going to be good or bad about this. But if we don't do our like due diligence to learn about it, we can't give an opinion on either. So
yeah. And at some point you just have to ship something. You have to say like, hey, we built a thing. Here's why it didn't work out and why you might want to use something else. So let's go ahead and jump into that interview, and we will see you all after to talk about the meta white paper I read. We'll talk it about it. It'll be fun.
What's up, friends? I'm here with Kyle Carberry, CTO at Coder.com. So Kyle, I've known Coder as the IDE in the cloud, and over time, you've iterated to become a fully open source cloud development environment, a CDE. How do you explain what Coder is and what it does?
Coder is a platform to provision you a development environment on any cloud infrastructure. That might be in a VM, that might be inside of a container, but Coder is kind of a developer's route to provision infrastructure for them to write software inside of. We started with the IDE, which is kind of like putting VS Code in the browser, which is what most people are certainly familiar with us for. And we kind of funneled that into more of a platform where people provision the infrastructure. And a lot of people do use a web IDE with Coder. A lot of people use a local IDE and just connect in.
Okay, so what are teams coming to you for? Who's coming to you?
What people really come to us for, particularly this problem is really exacerbated if you're a large enterprise, is when you have like 500 engineers that are trying to update like a version of Python. And instead, we allow one engineer to go through that tedious work of updating some scripts or some Docker container. And then you can actually just deploy that in one click to say like 500 engineers and make it really, really simple.
Let's laser focus in on the platform engineer. It is that team's job to provide the best infrastructure, the best platform for their given applications, for their teams. What are some signs or signals for platform engineers to think about when it might be time to consider a cloud development environment like Coder.com?
So as a platform engineer, developers might constantly be opening like IT tickets that their computer isn't working properly. They might constantly want to update dependencies, but that's a big mess. You constantly have to email people across your team to say, hey, Adam, could we update from Java 17 to Java 18? Those are the kinds of problems that people typically have. That's the status quo. You ship people more powerful laptops to improve the build times of your projects. You try to reduce the complexity of your products instead of simply, leveraging better hardware. We believe that the future is leveraging the cloud for a lot of these things. You can get more powerful instances in GCP or AWS that can make the build times faster instantly. You can let one developer create a standardized environment and then distribute it to 1,000 so that when you're updating from Java 17 to 18, it's just a simple pull request. You can co-locate your servers right next to something like S3 or a database that you're using in development so that you get immediate data transfers and it's not slow. Many of our customers, which is a crazy thing to say, but they use absolutely massive monorepos and they get clones that go from like 10 minutes or 20 minutes or an hour to simply like a minute or 30 seconds. It's just a lot simpler when all of your engineers are standardized on one centralized piece of infrastructure, and then one person can impact the lives of hundreds of engineers. And with that, we don't believe that everything belongs in the cloud. We think that some workloads are really amazing for it, and some are absolutely terrible. Coder should be a self-serve offering to your engineers. It should not be prescriptive, where you migrate all pieces of software development into the cloud. Only the things that really get a lot better by running them in this cloud-native way do we really promote moving.
Well, it might be time to consider a cloud development environment. And open source is awesome, and Coder is fully open source. You can go to Coder.com, get a demo, or try it right now, or even start a 30-day trial of Coder Enterprise. Once again, Coder.com, that's Coder.com, Coder.com.
Hello and welcome to the show, Duan Lightfoot. Duan's a developer advocate at AWS. Welcome and thanks for coming on the show.
Hey, thanks, Justin. Thanks, Autumn, and the whole Ship It community for having me on.
We met one time, I believe, at internal AWS DevRel summits, and you focused on networking at the time, and I think you still are. What do you do as a networking DA?
I basically do everything that I used to do my entire career, except for like the production side of engineering, right? But I'm still learning about networking, but specifically in the cloud and how it's being used for engineers on-prem as well as developers. And I kind of take everything I learn and explain it in a way that they understand, right? So if we're talking about hybrid connectivity, okay, let's talk to engineers about what that looks like on AWS. If we're talking about automating workloads with application networking or something, let's talk to developers about how we're doing this through Kubernetes and VPC Lattice and things like that. So I may do that through videos, blogs, conferences, wherever I need to go, wherever the community is and where they're at, I try to go there and meet them and, just help them grow in advance.
Where do you post your stuff? Because I'd love to learn about networking because I feel like always like when I was in networking classes, it felt like Charlie Brown's teacher talking to me. Like trying to do the math, and I'm just like, but why?
So traditionally, like before I started AWS, I had a YouTube channel. Lab Every Day was my YouTube channel, and so I posted a lot of stuff there. Also, before I joined AWS, I worked at Cisco, and so I made a lot of content at Cisco, specifically at DevNet. I even created a course, Python for Network Engineers, that Cisco sells to this day. And so now at AWS, I make content on, I would say I've done some blogs, but a lot of my content is in person because I find I like going to events, I like talking to people, and I like solving the problems that they actually have, right? Because a lot of the content that's out there has already been done because we have some amazing essays that have been talking about networking forever. So if you're looking for the content, networking content delivery is what it falls under, whether it's on blogs, whether it's on videos, whether it's on YouTube, you can find basically all the topics under that search.
How did you get into networking? Like, tell us like about your networking career before you got to be a DA.
Yeah. So how did I start in networking? Well, I went to the military back in the year 2000, right? So this was right after Y2K. And when I was in, my first course in tech was on networking. It was a course on the OSI model. And so it was like a 4-week course where we started from the physical layer, taking cables, plugging them in, splicing them, doing all types of things. This was when fiber, you had to do the figure eights and actually cut and splice your own fiber cables. And I think at the time we were on like Cat 3 Ethernet. So this was a long time ago. But yeah, that's how I actually got started, just in the military doing that. And yeah.
It seems like a lot of network engineers are former military because I think it's one of the like it gives a lot of good hands-on experience, like learning that type of skill.
Yeah, networking is one of those technologies where people either start at or come from somewhere else, like telecom. A lot of phone engineers that were doing analog phone systems or PBX phone systems, they migrated from doing that to network engineering. And then I actually listened to a lot of like CEOs from like Google and large companies. They actually started in networking for some reason. And yeah, it's just one of those things where people start at and then kind of go other directions.
I think it's like learning one of the harder pieces of engineering, like because network engineering is like very in-depth skill that is complicated to learn, but also like it's not one that you hear people making content for, and it's not like the sexy, like, oh, everybody should go learn this, like maybe the cloud or other things are, So what is different about learning networking in the cloud? Like what are you learning different working at AWS doing that kind of?
I think the first thing you have to understand is that it's the physical part, like the layer one side, like take that out of your mind. Even the layer 2 connectivity, kind of take that out of your mind and really start from that layer 3 when it comes to networking. So the IP addressing and the routing, all of that is there. So if you're getting started with networking on AWS, you're going to start at that Amazon VPC. So think of this like a container for all of your compute. You store your compute, whether it's EC2, you can actually connect to Lambda functions through databases, et cetera, through the VPC. And then from that VPC, you start to establish connectivity to different VPCs, other clouds, on-prem, and et cetera. So you're kind of building your own data center inside of that VPC.
I think a lot of the AWS abstractions and concepts are all just rooted in this data center sort of mindset of like, oh yeah, if you know what a data center is and you ran one before, AWS is going to feel right at home. And then I feel like some of these newer cloud environments like Cloudflare or something else, like they're like, it's like global workers. It's like, well, how does that work? What's going on here? Right? Like I have this thing that runs everywhere. Like you just like, I just ignore all the pieces below that layer of where your application is.
Yeah.
But what do you see? Because this is a Ship It show and this is all about people running applications and maintaining things. What's one of those like things you see people do incorrectly on a VPC when they create it that hit them like a year later when they're actually in production shipping code? Like what are those sort of like, is there something that you would call out and say like, you should do this when you're setting up your VPC the first time?
Yeah, I think people like oversizing VPCs or not thinking about like how subnets, like the actual use, right? Because some, like if you're on-prem, okay, I can do a whole /16 in my VPC, right? And then you do that, and then you have all these IP address conflicts, you have overlaps because you didn't right size that VPC. So I think just understanding what you really want to accomplish with your VPC, what type of workloads are going to live in there, right? How big will you want to scale those workloads to? And then kind of map that out in the beginning, and then make it easier as you start to connect to other regions, or maybe even connect to on-prem or even other clouds.
I think that overlap is really hard because how you set it up changes over time, right? And like what we create the first day is different than how we're using it in 3 years. And you have so many different orgs and other VPCs and overlaps, that becomes difficult. What's your take on IPv6?
I think IPv6 is good. I think IPv6 should be used more. If I'm a dreamer right now, right, and I'm thinking about networking, I think the way we allocate IPv4 IP addresses should be a thing of the past, right? If I don't know if you use VPC Lattice, but it has this concept of a service network, right? You create your service network, and then you create services that are associated with that service network. And when you create the service network, you get an IP address, IPv6 IP address space, and it handles all of the networking and DNS for each of your services. So let's say you have different VPCs and the services that are in those VPCs, and they need to communicate between the services. Normally, you would have to worry about ensuring there's no IP address overlap, but with the VPC Lattice, it handles all that for you because it's assigning IPv6 addresses, and it's kind of handling the communication with an PIPA address, the 169.254 that you'll never see. So it handles all of that connectivity within AWS, within the region, for your different VPCs and your services, removing the need to even have to worry about IPv4. So when I think about IPv6, I think that we should use it. It's so large that we don't really have to worry about overlaps and the challenges that we face. And then when we think about networking and routing and things, I think at the end of the day, what a network engineer's job is going to look a lot different in 10 years than it does today.
Because of the address space, or because of how things get?
Just because of what I think, like what I'm seeing with VPC Lattice, I think we could actually do that on a larger scale. An enterprise could actually do this maybe globally, to where they don't have to worry about routing within the enterprise. They could kind of just use IPv6 and DNS to, I would say, automatically connect devices to a specific domain or infrastructure without the need of saying, okay, let's deploy this router. Let's establish all the VLANs. Let's establish all the connectivity and the scopes that we need for IP address space. Everything is kind of done automatically. That's my thinking.
Let me just back up a little bit for anyone that's not familiar with VPC Lattice. VPC Lattice was one of the very first PR facts that I read inside of Amazon when I started. And I was excited for it because I was like, oh, this is really cool because you just handle all that stuff becomes invisible. But let me see if I describe it the way it's actually implemented, because I don't actually know the details under it. But essentially you have networks everywhere, and they all have their own subnets and IP address range. And Lattice comes in and attaches another virtual IP address that can route to anywhere else inside of AWS. It could also be a different account or different region or different VPC, and that can route to any other endpoints because of the way it handles it on almost like the back end of a VPC, or the back end. Instead of, a lot of people, you have to connect your VPC together with like star topology or these things like, oh, we have to interconnect these. Like, no, Lattice is just like, this application and this should be able to talk to these other applications. I don't care how they're connected. AWS, you route it. Is that roughly it?
It's region specific, right? So it's going to handle it within the region. So you have your service network. And your service network, think of if you need to connect two VPCs, right? You're either going to use something like VPC pairing, you're going to use maybe a VPN, or you could use a transit gateway, right, to establish connectivity between the two. With VPC Lattice, you create a service network and associate those VPCs with the service network. It doesn't matter what the IP addresses of the VPCs are. And then once you have a service within those VPCs, or a service that's created, it doesn't matter what the IP, let's say you got a Kubernetes cluster or a node or whatever, that service within Kubernetes, and it needs to communicate outside of Kubernetes or within Kubernetes. How are you going to connect to those services? Via IP address or the domain DNS, right? And so what it actually handles is that DNS, and it's using IPv6 rather than IPv4 to connect in between the services. So there's no need for a VPC parent, there's no need for a transit gateway, because the service network of VPC Lattice is kind of handling that for you.
Where do Bastion hosts come in?
Bastion hosts is if you're trying to connect, let's say, from the internet into a VPC that's in a private subnet.
Oh, okay.
Right? Because a private subnet, you don't want to have direct connectivity from the internet. You're going to go through a Bastion host, which will be in a public subnet, meaning that it's a subnet within a VPC that has connectivity from the internet.
So kind of like gates to make sure that you're staying secure.
Correct.
But if you're SSHing to prod, you're not.
Yeah.
You still might be having some problem. But yeah, I mean, it's like a proxy for SSH.
Right.
And you're like, oh, I need to get to that host.
I just want you to know that, like, I just wish I knew you when I was taking my AWS like solutions architect test, because there was just DNS and VPCs, and I was like, what is any of this?
Right.
And so much of cloud, or at least what I like to call like the traditional cloud, is networking fundamentals. And if you don't understand how to set up a network, you're gonna have a bad day once you're shipping something. You're like, oh, we need to expand, or we bought this company and we need to incorporate their stuff, because all of that peering immediately is like, oh, what's your IP address range? Oh, we can't route to you because IPv4 is not going to allow. I remember at Disney Plus, we literally they bought the startup and they're like, hey, we want you to be part of the Disney global network. We're like, no, like we use all those CIDRs. Like we can't route to you until you move
the CIDR math though, like nobody prepared me for all of them. Like nobody prepared me for that. Like, okay, so if you weren't in networking or really good at the cloud, how would you explain IVP4 versus 6 and why one is better, I guess?
Autumn, I told you we got like a half hour.
Okay, but like I think
Duan's gonna get it though. He's got this.
I think that it's different when like you read things, right? And then when you have someone like you to talk to, like it is so much better to learn in that way. And I think there's some things that we do great trying to create content for, but when you get to have a conversation about it, I think we can really teach people and help people, because there's so many things that they go into just enough information on like exams or like videos, but you still have questions, and it's cool to talk to someone like you who actually really thoroughly understands this stuff. So
yeah, IPv4 is 32-bit address. So if you're using like decimal to binary, that means you have 4 octets of 8. Right? Rather than with IPv6, it's going to be 120 bits and it's hexadecimal. And so if you're thinking about, let's say, something like IoT, Internet of Things, we only have so many usable IP addresses that are IPv4. And so with Internet of Things, you have billions of devices that need an IP address that could possibly connect to the internet. Well, if you try to do that with IPv4, we basically already ran out of space, right? IPv6 enables you to have, I don't know, I think it's billions of IP addresses.
I literally was setting up an EC2 instance 2 weeks ago. It took me 2 days to try to set up IPv6 so I could publicly hit this EC2. I failed. I didn't get it to work, but I learned a lot along the way, which is fine. So it wasn't a complete failure, but like the subnet you get from a VPC, because AWS assigns you an IPv6 CIDR, and it was like 16 quintillion addresses. It's just like, this is the smallest one we're going to give you. I'm like, I need one. Like I just want one IPv6, but like, it's such a large number, because there's only 4 billion IPv4 addresses. And you're just like, oh no, this is like IPv4 times IPv4 like 20 times. And it's just like, yeah, we're good.
Exactly.
Which is wild, because if you just look at your home network, like I have 4 satellites in my house because everything's connected to the internet nowadays, and it's crazy how many devices just in our house, you know what I mean? Like in regular things around our houses that are connected. Like my fridge is connected to my network because I have the fridge with the screen, and you know what I mean? Like it's just
when we talk about like home networks, you probably have one IPv4 address for your home. And everything is using a private IP address space, and then it's using something called NAT, network address translation, to communicate with the internet, right? So it looks like your one IPv4 address at home, but it's using a port to say, okay, when I'm communicating from my refrigerator, use this port right? Which is at layer 4. The layer 3 address is what's traversing the internet. When it comes back, it's saying, okay, I came in on this port, and then it goes back to your refrigerator. That's the layer 4. That's kind of why you need to understand the OSI model, because that works at the, I would say, the network to the transport layer, but it also, when you're dealing with your applications and you're understanding the port connectivity to your application, now, if you're serving a web server on port 80, you can't serve multiple web services on that port 80 if you already have one using port 80. So now you may have to have another web server running on port 8080.
So you just made networking interesting, and before it was just like Charlie Brown teaching. Now I'm going to go down a rabbit hole for 3 days and learn.
Autumn, your question about like the networking CIDR math. I found this tool called CIDR, which as I was doing IPv6, I was trying to split it up. Fantastic command line tool, because you can just say like, does this subnet overlap with that subnet? And you just give it this. I'm like, this is an amazing tool that I wish I would have found a long time ago. So I'm putting it in the show notes because I love it.
Because when I was a solutions architect and they made us go through TechU, and I'm sitting there trying to do like CIDR math, I was not ready. Like, I was like, I don't even know what a VPC is, and like a VPN and DNS and what. And like we went 8 hours a day for 4 weeks to learn about networking, and my head felt like you just jumbled things in it. Like now I understand it a lot more, but all at once it was a lot.
Yeah, it's way too much. And to the source nets problem, I worked at university for a while, and one of our network engineers had this great idea to save a bunch of money, which is fantastic. They used just non-commercial like end user IP address or network connectivity for the dorm rooms. And it had plenty of bandwidth because they were fast enough. It was like gigabit in the area or whatever. But what we ended up hitting was we ran out of open ports on the actual gateway because everyone was connecting to so many different things that you can use 65,000 ports and then you can't do anything about it. It was a fascinating outage learning a bunch about like, wait, how did this happen? And they're like, yeah, we just used all the ports on the gateway. I'm like, you can do that? Yep, sure enough.
This is like, when your friends say what happened was before they tell a ridiculous story. When anytime like the solutions architect to me, he was like, so somebody had an idea to save a bunch of money. I was like, oh no, where is this going? Like, it's never good. Like when it starts like that. Like it's always going to go left.
Yeah.
So, Joanne, you've been sharing a lot online about your learnings with AI stuff, and I'm kind of curious what that overlap is, what it is that you're trying to like move into or just explore the space, and how that affects what you do for teaching networking.
It's a tough thing because when you say AI, right, we understand that, okay, that's artificial intelligence. Well, under that, you have machine learning, and under that, you have deep learning, and then under that, you have generative AI. Right. And so a lot of what I was doing was around trying to understand generative AI. But the more I did that, the more I realized I didn't really understand, let's say, like deep learning or machine learning. So I kind of been going backwards and starting from the machine learning level, trying to understand that. So I went through a couple courses learning how to build my own GPT, my general purpose transformer, right? And that kind of showed me, okay, here's what's happening. Now I realize I need to understand math, right? So I need to go back and learn some more math. And also I need to understand algorithms, right? Because I need to know how that works. But that's just me trying to really understand what's going on so I can solve some problems that I want to have. Now for the generative AI side, is seeing how what we do every day, let's say as a network engineer. Back in like 2016, there was a real push to start using automation. Right. The challenge at that time was that many of the devices on premises, you had to connect through SSH, meaning that you're not dealing with structured data. Right. And so people were automating, that was happening. But now fast forward to, let's say like 2020, more devices were becoming API driven, along with more workloads were becoming hybrid as well as cloud native. So if you're dealing with APIs, you're dealing with structured data. So now you can really leverage the power of automation. Well, once you start doing that and you're automating, okay, that's great. But now with generative AI, you could actually take the API responses and let generative AI kind of handle them and then do something else, right? So now we're talking about agents, we're talking about you leveraging tools. The possibilities that are available to me are endless right now, and they really haven't been like thought of. Because when I think of myself, let's say working in a NOC or a SOC or somewhere where you have to log into all these different systems to find out, okay, why is there latency on my link? Well, one thing generative AI is great at is analyzing data. What if it had access to all of these logs? It had access to all of these APIs. You ask the question, why is there latency from on premises to another workload that's in another location or between sites, right? What if you could use generative AI in some type of chatbot that could make those API calls for you, analyze the data, and then return a response? And then once you return a response, then from there, what if you say, okay, contact this service provider to find out what's going on? And then it makes the request to the service provider, sending them an email. And then all of that is automated through this chatbot. Like, this is the type of possibilities I'm thinking of now. And
the first part of that isn't a Gen AI problem, right? Like getting access to data and categorizing the data, that's just straight machine learning, or pattern recognition. Like that's a regex, right? Like in a lot of cases, like, oh, search the logs for fail, error, whatever. And we grab some of that out and then present it in a way. But oftentimes there's too much of the data. There's like, as a single person trying to troubleshoot this, you're trying to fit all the context of everything that's going on. And that's where it gets really difficult, where troubleshooting my house is hard enough, right? I'm like TCP dump on one port, one ETH, like that's just going to stream everything to me. And I'm like, okay, now when I scale that out to a data center or multiple data centers, multiple applications, ignoring the noise is where that becomes a problem, because the Gen AI stuff doesn't play a factor in like, let's just collect the data and see what's going on. But presenting it to the person, I think, is the thing that like, hey, give me this in a way that I can understand the context of it and then know what's going on. That's a really interesting point about like just how that kind of shifts a little bit more into the human to computer interface and not just the data to human interface.
Think about, you remember the huge Reddit outage, and they had to go through like millions of lines of logs.
Yeah.
Imagine if generative AI was around then and how quickly they could have found that issue by leveraging generative AI.
And like, I'm trying to think, like, I'm sure, I don't remember what they had at the time, but they probably had like Elasticsearch, right? They probably had some way for them to search for the data because the logs were semi-structured and they're able to like, hey, we need to find this. But the person trying to fit all the context of not knowing what happened into this, like, we need to discover something and not knowing how all these complex systems plug together, especially at that networking layer, right? Like if this is a networking problem, you are below where most people are comfortable diving in, right? Where some people are like, oh, I'm going to look at my system logs. I was like, no, you need to look at like packets on the wire and figure out. I love that overlap of like networking is so physical, where it's like literally when you're tracing, like there's electrons that are flowing somewhere outside of the computer and you could like cut a wire and like, oh, look, they're gone. Right? Like you can actually affect that from the real world.
Yeah, that's true. But I think in the Reddit case, it was actually a CNI for one of the older Kubernetes workloads that wasn't compatible when they try to update that environment, right? And so if you're analyzing that, that's a whole application layer issue. You know what I mean?
I mean, that's encapsulated networks, right? And like that gets super tricky, super hard. I remember, I think it was Cilium is what they were using.
Yeah.
It was like the old version of Cilium had a problem with that version of Kubernetes, whatever it was at that scale. They're like, oh, you know what? These things are hard to put together and hard to verify, and one bit us.
Yeah. And I think that's one of the things VPC Lattice was trying to solve, not to market or talk about that, but when we talk about SEO and all these connectors, as far as container and application networking. But
I actually think that is awesome, because I had never heard of VPC Lattice, but it seems like it would solve a lot of problems that I ran into trying to like build things and experiment with it. So that's actually really cool.
Okay, friends, I'm here in the breaks with Annie Sexton over at Fly. Annie, we use Fly here at Changelog. We love Fly. It is such an awesome platform, and we love building on it. But for those who don't know much about Fly, what's special about building on Fly?
Fly gives you a lot of flexibility, like a lot of flexibility on multiple fronts. And on top of that, you get... So I've talked a lot about the networking, and that's obviously one thing, but there's various data stores that we partner with that are really easy to use. Actually, one of my favorite partners is Tigris. I can't say enough good things about them when it comes to object storage. I never in my life thought I would have so many opinions about object storage, but I do now. Tigris is a partner of Fly, and it's S3 compatible object storage that basically seems like it's a CDN, but is not. It's basically object storage storage that's globally distributed without needing to actually set up a CDN at all. It's like automatically distributed around the world. And it's also incredibly easy to use and set up. Like creating a bucket is literally one command. So it's partners like that that I think are this sort of extra icing on top of Fly that really makes it sort of the platform that has everything that you need.
So we use Tigress here at Changelog. Are they built on top of Fly? Is this one of those examples of being able to build on Fly?
Yeah, so Tigress is built on top of Fly's infrastructure, and that's what allows it to be globally distributed. I do have a video on this, but basically the way it works is whenever, like let's say a user uploads an asset to a particular bucket, well, that gets uploaded directly to the region closest to the user. Whereas with a CDN, there's sort of like a centralized place where assets need to get copied to, and then eventually they get sort of trickled out to all of the different global locations. Whereas with Tigress, the moment you upload something, it's available in that region instantly. And then it's eventually cached in all the other regions as well as it's requested. In fact, with Tigress, you don't even have to select which regions things are stored in. You just get these regions for free. And then on top of that, it is so much easier to work with. I feel like the way they manage permissions, the way they handle bucket creation, making things public or private is just so much simpler than other solutions. And the good news is that you don't actually need to change your code if you're already using S3. It's S3 compatible, so like whatever SDK you're using is probably just fine. And all you got to do is update the credentials. So it's super easy.
Very cool. Thanks, Annie. So Fly has everything you need. Over 3 million applications, including ours, here at Changelog. Multiple applications have launched on Fly. Boosted by global Anycast load balancing, zero configuration private networking, hardware isolation, instant WireGuard VPN connections, push button deployments that scale to thousands of instances. It's all there for you right now. Deploy your app in 5 minutes. Go to fly.io. Again, fly.io.
I thought what you said earlier was really interesting is when people just talk about AI, they talk about AI as one big, I guess, kind of glob of artificial intelligence, but really like machine learning, deep learning, generative AI. Like I think people think that you're going to use generative AI for everything, which it is got a lot of great uses. I use it all the time, like personally, but also machine learning is so interesting and so is deep learning. And it's like we almost forgot about it, which is wild because I think that is going to it's in so much of our life. Like Alexa's always like, you forgot to order popcorn. And I'm like, damn it, Alexa, stop spending my money. Cause like they get me every time. Alexa's like, I think you want to buy this. And I'm like, you're right, I do. So it's like, I feel like we've almost forgot like all these, actual, like, well, not actual, but like uses and these different cool things. And it's really, like you said, math, but we don't even think about that. Is there anything that you've like really enjoyed learning about deep learning or machine learning in your process of learning?
There's a lot that I've enjoyed learning, right? I think the most is developing applications, right? Because I'm not, one of the things, if I could do it again, I would go to school for computer science to learn to think like a developer, right? And so as I've been building out the applications that I'm building, it's challenging me more to think about how to really design this application and the problem I really want to solve, right? Especially when you start using tools, you have to route the request and the response and work with these large language models and then think about, okay, when I structure my prompt, how is the wording of this prompt going to affect this model at scale, right? Because I need this to be repeatable. And so when I'm designing these applications, it's really helping me think about things like that in a way that I haven't been challenged before.
I think that's really interesting because everybody thinks that coding and being an engineer is just the technical parts of writing code, right? But one of the most underrated skills of being an engineer is being able to ask good questions, good context, and do a good search, like even in Google, even if it's not prompt engineering. But I think prompt engineering teaches you how to be even more selective, and that is such an underrated skill. Like you are never going to have the answers to everything, but being able to go seek out the right answers, so underrated.
Yeah. Have you all used Perplexity AI?
I haven't. I usually stick to ChatGPT and Bedrock usually.
So when I use Perplexity, right, it's kind of like a research tool. So let's say you have a question about how do I use VPC Lattice, right? Or how do I set up a Kubernetes workload in AWS? How do I deploy that? It's going to ask the question, but then it's going to actually take your question and rephrase your question to other questions that you could be asking. And then it's going to analyze that and generate a response. But then under that, it's actually going to have the next question that you probably need to ask. And then you can click on that and kind of understand like how to think and the challenges you may face along this journey. And that's one of the things I like about it. I think Google has always done that at the bottom of the search, listed questions, next questions that people are asking.
Similar, yeah.
Yeah, but this actually does a way better job of that.
And I think that one of the things that Perplexity does really well is like exposing that path for you.
Yep.
Right. Because it's not just here's the next question or here's a similar question that other people are asking. It's not the SEO side of it. It's the how deep do you want to go into this and finding that. I've only used it a couple of times, but I mostly read about it in the news from all the data they scrape and what they're doing. That seems a little bit like, oh, maybe we shouldn't have done this, but also it's a useful tool. And that is a difficult thing to kind of come to terms with of like, hey, this thing adds value to my life and my learning, but also it has stolen information from people that would have tried to give me that as well, but I did not know how to get to them. I didn't know how to ask the question to find their content.
I wonder if they could somehow find a way to give back to those places by like, because I think that's my favorite use of AI is to learn. Like everybody expects AI to do for us, but I'm like, dude, AI could be a teacher. It is such a good, like sometimes to me, you can only read and do like listen to PowerPoints and videos for so long before your brain just kind of checks out. So asking AI questions and like almost using it to have a conversation about a new subject and then learning what I need to know and give you an overview and then I can go dive deep on things is one of my favorite like ways to use it.
Have you heard the Sal Khan from Khan Academy he had a TED talk about how AI was changing how people are learning because it allows that sort of like individualized tutorials and just like, hey, you ask me the next question. I'm not going to pretend I know where you're going to go through this flow. Like that tutorial becomes a lot shorter because you can just say like, I want this paragraph of information. Hey, which question is interesting next? And now we can go to the next question. And all of these things that we say, hey, here's an end to end from scratch to Kubernetes and AWS versus like, where do you want to start? Do you need to know how to do the VPC? How deep do you need? Are we calculating CIDRs here? Or are you just going to go pick the defaults and you don't care, right? And you can do that. And I think is a fascinating take on where this like overlap of learning and AI is. I think the gap is a lot of that, what you said, Autumn, like the giving back side, mostly because a lot of the online content is free because it's that you pay for it with marketing, right? Like you have to visit the website, you have to spend time on the website, and the AI bots don't do that. They're just like, give me the data. I'm going to take that back and just send it to someone else. There's situations like I was a DA, Duan, your DA, like we're professionally paid to make that content and it's offset by like, hey, you're paying me so I can make this content for you and that can live for free and I don't need to monetize it some other way. But there's a lot of other people and companies and content out there that's not that. And being able to figure out how to give back in those areas is really tricky.
If you all get a chance, there's an interview that the old Google CEO, Eric Schmidt, did. It actually got banned and taken down.
The Stanford, yeah.
So in the interview, he mentioned something about how creators of content, a way that they could actually get paid. So I don't know if you all have ever done music, but there's something called like ASCAP, right? Well, if you make a song and it get plays on the radio, the way you get paid is by the number of times it's played. You register with ASCAP, and ASCAP tracks all of this across all radio stations and wherever your music is played. And then they send you a check based off those number of plays. And so what he's saying is that there probably will need to be some type of ASCAP for texts and images that people post publicly, and then they get a percentage of that revenue back from the content they pay. And I'm like, I could see that. I actually could see that.
I like that. It would suggest the actual links and tell people like, hey, this is a blurb. Now go click on this link. So you still get your clicks, right? But because it's like, instead of trying to fight change, we just need to embrace it. Like, when you see all these people that are old trying to make laws in like Congress and you're like, bro, you don't even know what TikTok is. Like, you know what I mean? Like, why are you
old people making laws? That's a problem.
Like, you don't even like, you don't even know what TikTok is. How are you going to make a law for it? Instead of trying to fight change, let's find a way to make it better.
So, Duan, when we started this, you said that you made a course for Cisco, and they're still selling it to this day, right? And you don't, they're making money, getting people from it. You don't make a dime from that. And I think of that, and I contrast that to the movie industry, because like, why does the movie industry have royalty checks? Why does that exist? Why is and why even is like the end of a movie have 20 minutes of names on a list that I'm gonna not sit through usually, right? Like why does that even exist? And most of that comes down to the unions and the fact that workers have power, and the workers, the people that do the actual work to create the thing, have a voice to say like, hey, we collectively can say, no, you cannot do this anymore. And I feel like that's a really big missing piece in this like free world of the internet and content creation, and all of the individual creators have no collective power, which I find really interesting. I'm not like a super union person, but when I contrast those things and I say, oh, I worked in the movie industry and it was very unionized, and it was unionized because those people were individuals and they float between studios and they do a lot of different projects, but then collectively they can say, we're not going to do that unless you're paying us correctly, and we're going to go on strike. But YouTubers and TikToks, they're not going on strike because someone else can come in and just create the content for you, and then it kind of goes through, and there's no way to get those residuals.
That's actually really interesting too, because like if you look at it, so when Microsoft bought LinkedIn and all the different things happened and LinkedIn laid off their content team, now we all get those emails saying, hey, do you want to contribute to this? But like, it makes me feel bad because we're contributing to them getting rid of content creators, right? Like the people that we all learned from to get these amazing careers. So it's like, I wonder, like, and then just the layoffs that's going on in engineering and stuff. I wonder if, like, a lot of people talk about engineering, like unions. So that's actually really interesting, your take, Justin, and how those could relate.
Well, and that happened over, 100 years of like how movie industries were treating people that work for them. Because back in the day, like if you remember way back in the day, like Cary Grant and stuff, they worked for a studio. Like that was just like they worked for one studio. They were hired by the studio, and they were like the face of that studio.
Oh, I didn't know that.
Yeah, and then a lot of stuff changed in the early 20s. Like this golden era of movies shifted when basically the government broke up the movie theaters. Like you cannot own the full stack. You can't own the movie theater, the studio that creates the content, and the people that are working for you, because you can treat all of them poorly. And so they had to break it up and say, you get a movie theater over here. That's an external company. And now the actors and actresses, they broke contracts and they didn't have to work for a studio, and they could go around, but then they still needed some collective way to say, hey, don't treat me like crap.
Which is funny because that now kind of like, look at all the monopolies that they're breaking up in tech too, right? So that's like funny. This also kind of goes back to what we were talking about a couple of weeks ago about how when you have a different background that's not a traditional tech background, like I think it makes you so like you bring more to the table. Like think about all the different things. Like you were in the military, right? Justin used to work in animation and like all the other things that you did beforehand. And I just think like all the people that we meet, like that did theater and all these cool things, like it brings such a perspective to building software,
Yeah. You mentioned the monopolies. Like if you look at Google and what they're going, I don't know if you paid attention to the case that they're going through now, but
which one?
I know there's like 3, but the big one is the search monopoly, right?
Yeah, the search monopoly, because the number one search engine for the longest time was Google, right? And then from there, the number one search engine was YouTube. So I think now it's TikTok, but still number 2 and 3 is Google and YouTube. So they own both of those, right? And then the advertising for both of those, they own that too. So they control that entire market. If you think about a monopoly,
not just that, but that's a dangerous monopoly because that's how people get their information, right? So I'm not saying Google's doing anything wrong right now, but if somebody evil took over Google and they were like, we're only going to feed you misinformation, how would we, like, look at how it's the SEOs or whatever, like how they give you the stuff that's sponsored before the stuff that's actually like.
I also think that like monopolies, I don't want to say they're not bad, but they're useful to me as a consumer, right? Like I know a lot of startups and tech companies that want to be the new Apple. And what is Apple but a monopoly? Like they own the hardware, the OS, your phone, your headphones, your services on top of it. And like I'm trying to back up my iPad, and it's like a terabyte iPad, and I'm like, oh, I gotta like up my plan by like 2 factors, and I have no other option, right? Like
Yes.
I can't plug in a drive and say, please back up and restore from this thing. I could back up my photos certain ways. I could do certain pieces, but not what Apple gives me as a monopoly stack to own the entire thing.
And can we talk about it? I love Apple for that monopoly because I love that my phone and my laptop.
People love the
and
simplicity.
yes, because I don't. It's the undifferentiated heavy lifting of your life, right? Like you don't have to think about all those little pieces, and now all of a sudden it's syncing, and my kid stuff works, and I have a family like thing. But then at the same time, they also own a lot of my data and are in a lot of my business. So you're just like,
But Justin makes a great point, right? Because when I tried to go to, I remember I've had it since the iPhone 3. And when I used to back up my iPhone 3, I would back it up to I would have Apple, it was iTunes at the time.
Yeah, hey, you
right?
plug in iTunes,
Yeah, I would plug in iTunes on my computer and back it up that way. As well as I could just open up a drive on my iPhone and look at the pictures. Like it was just a drive and I could copy those pictures over. But now it's not that simple. Like you can't do those things anymore.
Yeah. And monopolies are great until they're not. And that's the problem is like, where's the line of like, this is useful to me and you own the whole stack versus you are now either treating people poorly or prices are going up and all of that stuff. Like the competitive nature needs to still exist. Like competition has to be there and it's just not for certain things. And look what happens to Apple in the European Union, right? Like the third-party app stores are out now. And you can go get a third-party app store, which is like incredible to me that is a thing that exists. And I'm like, that should exist worldwide, in my opinion. And so many other things in competition could happen if you get those deeper hooks into things. And most of the time, that just only happens through regulation and saying the government's like, actually, there's no competition here. We need to force you to open up to make sure that someone can make some money off of the things that you've engineered and built.
And I want to be clear, I'm not calling no company a monopoly. That's not up for me to decide, right? I just think that sometimes companies get so big that it makes it hard to get out of that ecosystem to do things in a way that are, I would say, maybe more beneficial for the user or the consumer if they were outside of the ecosystem.
I tried to switch to Samsung a couple of years ago after having an iPhone for so long. I had to switch back. Like I couldn't do it. Like I was like, Apple's got me. People like every time I'm like, I meet someone and it's like a green bubble and I'm like, but why though? Like, like why would you do that to yourself? Like,
they're even getting RCS now. Like again, another technical like thing that was required to say, hey, you have to support this better protocol that's more secure, that has better features. And Apple dragged their feet to be like, oh, SMS, right? You 120 characters.
And the chargers and stuff. But this all goes back to what we were just talking about. We need people that are educated enough in technology to make these laws. Like, I don't know if the people that we have in positions of political power in the United States have enough background in technology to even be able to make these laws. Like, I don't know what they're doing different in the EU, but I like half of the, like, have you ever seen them argue about technology on the Senate floor? I'm like, who do these people talk to? Like, pay one of us because like we'll help you. Like, what?
More senators need to know the OSI model, and I think that's the full circle.
They don't even know Nancy Pelosi was trying to talk about algorithms. I about had a heart attack. Like, what are we doing? I was like, can you please talk to a human that's under 40, maybe 40? Like, I don't know. It's wild.
Duan, this has been really fun. Thank you so much for coming on the show. Where should people find you if they want to reach out online or find some of the videos and content you're making?
Yeah, you can find me at Lab Every Day on all social media platforms. Just keep it simple.
Look, I want to find your content. Teach me about networking. You make it make sense. And look, we need to be friends because I want to understand networking so bad because it really relates to so many things in the cloud. But sometimes I'm just like, who wrote this? Like, did they, like I think people that have write about networking that have done networking for so long, I'm like, can you explain it to me in English and like normal, like.
Yeah, that's the purpose of generative AI. Copy and paste it and tell it to explain it to you like
that's what I do. I even use it to interview me sometimes. I'm like, ask me these questions, change it this way. And it really works. I'm telling you.
All right. Thank you so much for coming on the show. And we'll talk to you again later.
Yeah. Thanks.
What's up, friends? I'm here in the breaks with my good friend, my new friend, Kyle Spearin, the creator of Bitwarden, the open source password manager you know and love. And now they have secrets management for teams, for you, for your infrastructure, for all the things. So Kyle, I know that Bitwarden has deep roots. Take me to the beginning. How did you begin this thing?
The early stages of Bitwarden came from me wanting to create something that was really easy to use so that lots of people could adopt it and use it, but also appeal to people who are like-minded like myself, who really like the open source message and the benefits of open source technology and what that brings to the market. Fast forward several years of kind of doing that, there was a lot of untapped potential too in the product, but there's a lot of things I don't, have strengths in, and where I thought I could bring in outside help to help me. And I helped develop that over the course of several years of running the product and build those right relationships with the right people. And then once I was ready to kind of accept that help, I brought people in and we really took the business to the next level of where it could be. And now we have, millions and millions and millions of users using our product today. And we have multiple products that we really service the kind of security industry with.
Okay, so now you've scaled, you've got millions and millions and millions of users deep into password management, and you've scaled the team, you've scaled the product, you've scaled the company, and now you have secrets management for teams, for infrastructure, for all the things. What are some of the key concerns that made you go this direction?
There's a sprawl of secrets for, think about how large your environment is and all the things and all the endpoints and machines you have to manage to kind of orchestrate and make this whole thing work, right? Like there are tools that help you do all that, but all those tools are using secrets in different ways, right? You end up with this sprawl of secrets that are everywhere, much like the sprawl of secrets you have in password management of all the services you use on the internet. It's kind of overwhelming. Like I think a lot of people, if you would ask how many different passwords or secrets that you have that you kind of use across the internet, if I had to bet, almost all of them would underestimate the value that they actually are. And once you understand the depth of the sprawl you have, it's a challenge to figure out how you're going to do that and what tool you're going to find to kind of manage that. In addition to the sprawl, there's also the sprawl of your organization itself, the human element of it as well, which, at every company, there are people who come and there are people who go, and there are people who need access to certain secrets and there are people who don't need access to other secrets. And that's also a very challenging problem to solve. Part of the core feature set of what Bitwarden Secrets Manager is solving are those two problems. How do you manage from a single pane of glass all the secrets you need to use throughout your environments and infrastructure? And then how do you control who has access to those secrets in a kind of least privilege access way that creates the best security practices that you need to secure your organization?
Okay, get streamlined secrets management for developers at bitwarden.com/secrets. Get end-to-end encrypted Bitwarden Secrets Manager, clean up your hygiene for your secrets, secure your infrastructure, your machine secrets, and your developer secrets. Start a free 7-day Bitwarden Secrets Manager trial today at bitwarden.com/secrets. That's bitwarden.com/secrets.
All right, thank you so much, Duan, for the interview, and actually, you're sticking around for the outro because we were just talking and we're just like, let's just keep going. We got 20 more minutes, and we were figuring out the outro piece. So, thanks for sticking with us right now.
No problem. I'm excited.
Yeah, the outro we wanted to go over was actually the new Meta Llama 3 white paper, and I finished this paper this last week, and it was a struggle. It probably took me 2 weeks to read the thing. It's like 74 pages. And it is one of the most dense white papers I've read for a long time.
Look, I'm just going to be honest. I did not finish that paper. I was in pain watching you finish the paper. I've never Googled so many acronyms in the first page of a white paper in my life. Like
every section had new acronyms and at least 2 or 3 other resources. Like, hey, we're just referencing this other major work from this other white paper. And I'm like,
I actually thought that was really cool though. Like Meta does, I don't always agree with them, but the way that they outsource like in open source things, like it's amazing how like transparent they'll be and how they give a lot of information and that they give credit to the other white papers that they learned it from. I really appreciate that about them.
To me, this really, what we were just talking about in the interview, right? Like summarizing a website and content and then saying, this is what I'm using. And like, hey, when you go ask the AI and say, hey, what does that website say? You're giving the credit because you're like, they came from here, but no one's going there, right? Like I'm not reading all these white papers and then figuring out the depth of it because sometimes these references, they get it wrong.
Yeah.
And that is one of the most fascinating pieces to me about this whole like academic infrastructure of like how these white papers reference each other, and they get like bonus points the more they're referenced and all this stuff. Like, you know, like that is a very interesting area, but that's not what we want to talk about today.
That stood out to me a lot, that they gave people not just credit, but they were like, here, you can go learn more about this, which I really appreciated, because people, like, I had friends that worked in academia, and they spend like years and months of their lives writing these papers, you know? So to give them credit back was really cool.
Yeah. And the fact that there are so many references makes me assume that this isn't AI generated, but also from other news or court cases and whatnot are making up some like thing that's not, doesn't actually exist. Because I have read some AI white papers and I'm like, you generated this.
Yeah.
Like, I know for a fact, like, you don't have to tell me that like some AI, like, I don't have to do the test. I was like, this whole section, you just generated it and made a couple edits and that was it. And so,
it also makes me feel like I trust the source more. Like when I'm reading something, maybe like
they give all the references.
Yeah. Well, because like, it's like when you are having a Facebook argument versus a college essay, right? Like when you have to like quote your sources, and I know that you actually did the research, obviously they're going to do the research, but you know what I mean? Like it just gives you more street cred to me.
So here's the 3 things that I learned from reading this paper. And there's a bunch of stuff in it. Again, it's like 74 pages long, but these were the things that I kind of took away. And I'm like, oh, that's fascinating. And one of them I remember came out a little while ago, where the hardware alone that Meta trains the Llama 3. And again, if people aren't familiar, this is an open model from Meta. Llama 3 comes in 3 different sizes. There's an 8 billion, a 70 billion, and a 405 billion parameter models. So you can get different sizes. You can run it locally with something like Llama. And it's out there. It's not a completely open model because there's no standard for what open means. And if you're a company using this, like if you're over a certain revenue, like you can't use it, all this stuff. But for my intents and purposes, as someone learning the stack and trying to play with it and learn more about like how they built it, it's open enough for me to understand what they're doing under the hood here. So the first thing is just the training side of it. They used over 24,000 H100 GPUs. 24,000. They had their infrastructure is more than that, but this is just like this is for the Llama 3. We use 24,000. That alone is over $700 million.
Wow.
That's just the GPUs. And looking at like the infrastructure diagrams they have in here, all of the like high bandwidth, because this isn't like, Dwan, this isn't like straight up Ethernet networking. Like this is like, what's the link? Oculink, not Oculink. There's
InfiniBand.
InfiniBand. Yeah. This is, and InfiniBand's super expensive, right? Like you're doing InfiniBand between nodes, and inside of a node, they have multiple GPUs with high bandwidth between the PCI buses. And then they do InfiniBand between external nodes to say like, oh, we need to go talk to that node over there and send data. And that's not your normal switch. Like you're not.
I've been talking to a lot of engineers about NVIDIA and data center networking for these type of workloads. A lot of engineers don't know it, but I think it's a lot of opportunity for them to get up to speed and maybe, shift their careers to this area where not too many people have the expertise.
Ooh, that's an interesting upskill and pivot, because I think a lot of people right now are scrambling, like, how do we upskill to make ourselves marketable in this new market? That is a really interesting pivot.
So just the GPUs alone, over $700 million. I'm assuming the rest of the hardware, they're well over $1 billion on just like buying racks and stacks and computers and network and all that stuff. And then you got the people that literally actually train it and do the rest of the stuff. It's just they're billions and billions of dollars. I think.
What about the power source? Like just like, you know what I mean? Like I really wish somebody would tell us like how much electricity and like, because that's a resource, right? Like we were very into like climate change and all that stuff a couple of years ago, and now we're just like, light it on fire. Like, yo, like I want to be able to go outside later.
The power side of it, and also just the general like heat usage, brings me to the second point that I found. Like the first time that I like stopped and reread a sentence in this paper like 4 times, I was like, wait, what? They say that not only do they have failures all the time with these GPUs, I forget what the rate was. I'm trying to search for it and I couldn't find it.
When you say GPUs, do you just mean the chips?
Yeah, like the chips in the GPUs, like some failure, and they break it down in the paper of like how much.
Oh, okay, like what was the main failures that they talked about? If you don't have it, it's totally fine. I will eventually struggle through and read them, but it's just interesting. Like you wouldn't think about some failures that you get when you're really in depth in something, you know?
And this is one of the things that I wish that Apple Books had a better search for PDF. I could probably just pull up the PDF straight up. And
So one thing that you could do is actually, I don't know if you use any type of large language models, chatbots, right? You could take the PDF and then just put
Upload
it
it.
in
Yeah,
there and then
Which
ask the
ones can you do
questions.
that? Because
All of
that's
them.
how
ChatGPT
I
can.
learn. What?
All of
Okay,
them.
so I
Yeah.
can put it in ChatGPT and then ask questions about it?
Yes, you can.
Yes, because that is how I learn. Like I need to be able to have that conversation. So that is fire. I might actually make it through this white paper, y'all. Like, like I love a new like way to learn. I like read books on how to like hack your brain to learn more, so that I'm all for it.
Another thing, there's actually and I'll send you the repo as well, but there's a Bedrock Cloud chatbot that you can deploy in your account. And then it'll give you a chatbot where you can actually take, and I don't know if you know anything about RAG, retrieval augmented generation.
Oh yeah, I read about that.
Yeah, so you could take like a link to the white paper, add it to your RAG, your data store, and then it'll take it. And now you can ask questions about it, but you can add additional docs. And so now when you actually ask the question, it'll reference that point in the doc. Because now, like if you use ChatGPT or Claude, it's not going to reference where it got that information in the doc. So you don't really know if it hallucinated. So you still need to kind of research.
Yes, that's what I want, because like sometimes I've like used ChatGPT to learn things, but then I have to go back and there's so much work to verify, and I never want to speak on something that you're still learning and get it wrong. So I think that would be really beneficial, because I am always really worried about like I don't want to say something in a talk or like teach a class and not have all the information. So that I think that would help me utilize AI to like learn more and to be more confident in my answers.
Yeah, RAG can help you do that. But I'll be quiet so Jess can keep going.
No,
I'm mad at you now because that completely worked. This is like I uploaded the paper.
Shut up!
It's completely worked. And I said,
look at you. That was fire.
super mad at you right now.
That's why
real time over here.
You kept that conversation going just enough. I uploaded the paper and I asked it, how many GPU failures did Meta have in this paper?
What did you upload it to? ChatGPT?
ChatGPT, yeah.
What?
Yeah.
I love this.
And yeah, it doesn't give me the table. Like I wish it would tell me where. I want that in the doc, like what page or whatever.
Yeah,
but it was 30% of the failures were hardware failures on the GPUs.
Okay.
It was 148 failures. They trained over a 54-day period, so like roughly 2 months or so. They had 148 GPUs just like dead, like just fail. And they had 419 other failures, but like some of them were like OS updates and things that were like, oh, we interrupted you for whatever reason. But 30%, the majority of it was hardware GPUs just died. And those are expensive GPUs.
Yeah, it's very interesting. Like, because I wonder, like, when you go into a model and they like say they go on their next like research project, do they now have to account for 30% more GPU just to cover?
Be able to say like we need to finish on this time or whatever. Yeah.
So there's two things. I would modify your prompt to give you a excerpt from the actual document where it received the information, right? So say, okay, ask the question, then say provide a direct source to the information from the document.
Give me the quote or the link or something.
That is fire. Yes.
When we're talking about these GPUs, what I find interesting is that they can do like distributed training. And so you got these 20,000 GPUs, and you would think when you're training a large language model, you're using it to train these one model, right?
A thing, yeah.
Right. But they actually can break the workloads down and do parallelism and distributed training. So it trains a little bit over here, it trains a little bit over here, it trains a little bit over here to make it more efficient. And then they go back and kind of glue it all together.
As an infrastructure nerd, that was the most interesting section to me because they did break down how they separated that out. Because they're like, hey, do we want to base this on like types of information that we want across nodes? Do we want this on type of queries or type of use cases?
So is it kind of like spot instances in the cloud?
No, because this is just like one node is going to have, however much memory in GPUs that's high bandwidth on the PCI bus. And they're like, hey, but I need to go talk to another node to get information about something else that I don't have the data for, because these data sets are huge. And so they're like, I gotta go find
in a
the
database.
Data. And yeah, so it's kind of like distributed database. How do you shard it?
Yes. Okay. Now we're speaking my language.
And that's exactly it. And so they say like how we're going to shard the data depends on how fast we can query it and how efficiently we can actually train the model. Because if we're going to do multiple round trips, if we can save that and put it on the same node, that's so much faster. It was like 10, so much faster just to go locally.
I wonder if that also saves on networking costs and different things too.
Well, and so the second piece of like how are they planning for 30% more or whatever, like to compensate for failures. The thing that I read over and over again was in the paper, they say they had a 1 to 2% throughput depending on the time of day. If you train your AI models at night, you will just save 2%.
But aren't they the only people that are training on that stuff, or are they using?
No. So many people are like, "Hey, much smaller scale, right?" Because Meta, like, let's say it's $1 billion for infrastructure, you can save 2% on $1 billion. Is like, oh, actually, I can go hire someone else, right? Like,
Yeah.
But even smaller companies, they're like, "Hey, I have a team. We're trying to train something. We want to build some stuff. We have our own data center. If you can spend the time to work on things during the day and just train at nights, they're like, actually, we just got better throughput." Just the models worked better because the atmosphere was cooler and things just worked better. Like it was a heat thing.
Oh, okay. I didn't think about the atmosphere being cooler. I didn't.
Yeah.
I was thinking about like shared infrastructure and other things are running, but I'm like, if they bought that infrastructure just for that, nothing else would be running.
This is all on-prem. This is all their stuff. This is dedicated to them. And they're just like, throughput was better 1 to 2% by just going at night.
That is wild.
I could not believe. I read that one so many times. Like, what are you talking about?
I would have never considered that in the heat.
And this is a data center, right? This is controlled environments. And you're like, oh, well, you control the AC. Just turn the AC down a couple clicks, right? And you're fine. And like, no. It's like someone's dad's over there. Like, you can't turn down the AC right now.
Well, not just that, but certain places like in Virginia, like when I lived there was like, you could be running an AC, but the humidity and like, you know what I mean? You'd have to get a dehumidifier and run that at the same time as your AC. So like, can you imagine just when it drops at night, it probably is working so much more efficiently, even with the AC,
I wonder though, how do they break the workloads down to just train at night, or did they just monitor it continuously?
They just monitored. Yeah.
Okay,
I mean, because they were trying to cram it into like a short period of time. So I don't think that they were going to they wouldn't extend out their training by double the time by saying we're only going to do this at night. Right. So just like, oh, we're actually going to train all the time. But they noticed their throughput dropped during the day.
Okay. Yeah. Cause I don't even think you could break it out to say we're only going to train at night.
They have a lot of snapshotting, like because of the failures and because of things. They're like, oh, we snapshot a lot so we can restore from a previous state. It does take time. It's not free, but there was a lot of things they talk about in the paper of like, how do we avoid some of these outages that were unexpected? Or how do we make sure that the expected interruptions wouldn't cause big problems? And so they can we snapshot this workload. We can just basically drain the GPU memory and then restore it back at some point and say like, oh, you're good now. Go just keep doing what you were doing.
That's so interesting.
So the last piece that I found really interesting was in the conclusion. And Autumn, when I was reading this, I was thinking of you because this was exactly what you had talked about previously at Scale with your talk and various things about just like diversity inside of these data sets and LLMs. And what I'm calling the Conway's LLM, because they call out that they separated out who was testing the prompts and responses versus who was training the models. And they said that improved their actual accuracy for use cases so much more than having those integrated team and saying the person training the model is the best expert to prompt the model and then to validate the solution, because that stack just made so much biases against like, oh, well, we know what we want. And so we're just going to train a little bit more because everything about an LLM is adding bias. Right? Everything in here is just like, we need it to be more biased towards how a person acts or how a person expects to respond, something like that. So everything's about like, well, what type of person, what type of environment, what's the use case? And they say by separating those out organizationally, and they said they have two different, let me read the quote here. We ensure that our human evaluations remain trustworthy by allowing only a small set of researchers who do not contribute to model development to perform and access evaluations. It says that while organizational decisions are rarely discussed on technical papers, we found them to be pivotal to the successful development of Llama 3 family of models.
That's fire.
So literally your org chart is the reason that Llama 3 is successful.
I'm going to cite that in my GitHub talk. But like, I really think that like we're out here acting like diversity and inclusion is some sort of charity work. And I'm like, so we're just going to ignore return on investment and building good software and having to iterate because you made a mistake that nobody caught because you didn't have diverse like perspectives in the room. Like, let's make good software. This is not charity. This is good business.
And they don't even address like the diversity piece. They just say by having a firewall between these two components of the model benefited our model. And it's like, okay, now I want to talk about like, let's go one step further than that. Like, what else do we need to make this data? Because they even call out like the fundamental things that they needed was just good, clean data. And they're like, we just have that data. We have to have that data. We pay for it in a lot of places. And if you don't have that data, you cannot ever even start with Gen AI.
I mean, Gen AI, machine learning, like deep learning, all of it. If you put bad in, you will get bad out, you know?
Well, that's what I was going to ask. You said they pay for it because one of the topics that I've been reading about is synthetic data, like using generative AI to output training data.
And they talk a lot about that in areas they use that, because that was another kind of piece that I thought was interesting, where these models and use cases are so varied and so large that they couldn't pay enough people to make enough data in time. And so they had to train, they used a lot of Llama 2 to say, hey, we want you to like make data that looks like this in these scenarios and help us get information out. So they have basically clean data to like start. And then they have an AI model that's like creating new synthetic data based on that, their new model training off it, and then another AI model like judging it in some cases. And there was a lot of human feedback loop on that judging piece of like, you did it wrong, Llama 2, like let's go ahead and adjust these and tweak these areas. But in most of those cases, the synthetic data generation and the judging, they weren't general purpose LLMs. Most of them were very specific. It was more of the traditional machine learning side of things instead of the generate the world for me. And so a lot of those cases are like, it was Llama 2 based, but reading through between the lines on a lot of it was like, oh, this isn't Llama 2 with ChatGPT. This is just like, you're using a machine learning model to like figure out that data, make a new version of it. And it seemed like specific.
That's wild. That's dog fooding on a new level. Like,
and at that scale, like they had to, which was fascinating because it's like they talk a lot about comparisons, which are fine. I didn't know that there was this many like LLM comparison and charts and things that like, oh, we did all these tests and all these test beds. I'm like, I didn't know this existed.
Yeah, I've been trying to dig deeper on that stuff. I took a PyTorch class a long time ago, and I did not realize how much calculus and like linear algebra and all that, like
machine learning. Yeah.
Them algorithms. The crazy part to me is like, it'll have this much data, right? And then be able to compress a model down to where it's like downloadable. You know what I mean? To be a couple 100 gigs.
And compression alone is its own algorithms and complexity and math, you know? So when you think of it all together, it's amazing. Like think about what human computers were doing, you know, 50 years ago or 40 years ago, and then how far we've come.
Yeah. I think that because like if you look at like the deep learning side and how a lot of the data is just removed during compression, but it's still able to establish the relationship and infer how to respond to your question. Even though a lot of that data has been removed, it just understands the relationships in those neural networks. And that's the part I've been trying to learn. Like that to me it's crazy. Like it's magic.
I think deep learning and machine learning are so like they're not even getting the attention they deserve during the generative AI boom. And that is like, I'm not saying, I think I use generative AI a lot, but I think that deep learning and machine learning is where we're going to get most of the really impactful use cases.
Well, and machine learning walked so Gen AI could run, right? Like that's the
but it did, but people act like it, like we're just over here like let's prompt everything, and I'm like, you couldn't prompt things if we didn't have machine learning. Like, you know. And
Dewan, to your point, like I downloaded the Llama models, all three of them, to my computer so I could like try them out locally while as I was reading this paper. The 8 billion model is just under 5 gigs. The 70 billion model is 40 gigs, and the 405 billion model is 229 gigs.
Exactly.
That is wild.
I mean, that's like, it's, 300 gigs on my computer to like go play with this thing and see how it works and kind of prompt it myself. And a lot of their testing in the paper is like the 405 billion model obviously is the best one. And it's competitive to a lot of the closed source models in various tests. But it was fascinating just seeing like how they walk through this. Again, with references, it's almost 100 pages of white paper. I don't recommend that everyone read it, but absolutely go put this in ChatGPT and ask some questions because I'm
going to do that. I'm trying to dig deep on all that stuff.
All right. Well, thank you so much, everyone, for listening to the show. And Dewan, again, thanks for joining and talking to us all about networking and AI stuff. This is fun. And we will talk to you all again soon.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.